now. Okay, so welcome to class. Today we are going to talk about the moon. So this is a new unit, okay, and we are going to be able to talk about the moon, the different aspects of the moon. Today we are going to talk about the physical aspects of the moon and some of the effects that has on us. And we are going to not talk about the phases of the moon or eclipses. We'll have that in the next classes. Okay, so let's get going with that. So here we have a picture. I'm going to show you 4 pictures of the different sides of the moon. So this picture is the near side of the moon, or the side of the moon that we always see from the Earth. Okay. Does anybody know why we always see the same side of the moon all the time? Why is that? Any ideas? Did you know that? Did you know that?
Why do we always see the same side of the moon?
Yes, yeah. Did you know that we always see the same side of the moon?
I can't see the presentation.
Oh, that's right. Yeah, sorry, I forgot to show the screen. Okay. Okay. Can you see that now? Thank you. That was my bad. All right. Everybody is okay now? I have to remember to do so many things at the same time. So okay, so the question is, why do we always see the same side of the moon? Did you know that we always see the same side of the moon? And why is that? We're going to apparently no one knows. Okay, so that's all right. We are going to talk about that today in the class. Okay, so this is the side of the moon that we see. Okay, so it says, my brother says that it's because of the dark spots, iron, gravitating towards the Earth. I didn't realize that. It moves along with us. Okay, so it is kind of related to that. Okay, to these darker spots, but not directly because of the darker spots. Okay, but we will talk about why is it that we have these darker spots, what are they, and how do those influence that. Okay, so yes, so the moon rotates in a synchronous way. Okay, it rotates around the Earth, or in an orbit around the Earth, but also is locked, always facing the same way. Okay, so Ashley and Kenzie, when you say there it doesn't rotate, it actually does rotate. Okay, it doesn't have to do with magnetic forces. It also has to do with the gravitational forces, and we'll see how that works in a little bit. All right, so let's see. This is the far side of the moon. Okay, what are the things that you notice that are the same and things that are different between the far side of the moon and the near side of the moon? Near side means that this is the side that we always see, that is always facing us, near us. Okay? All right, and the far side is the side that we cannot see. And so, Sabrina, you say that it doesn't have as many iron spots. Okay? That is true, that is correct if you refer to the iron spots as these darker spots. They are not really iron, all right? basaltic basins, all right, that are kind of, they are the remnants of volcanic activity. And yes, you see that there's a lot more impact marks on the far side. Okay, so there's lots more craters on the far side than on the near side. Okay, it is not as bright. What do you mean? So I don't know what you mean by it's not as bright. Okay, well, that may be because of the color. It doesn't look as cool. Which one doesn't look as cool? The far side or the near side? The moon took the hits for us. That is true. The far side, it means that it's not that cool. It doesn't seem as interesting, really, as the near side. The near side seems to have, lots more things going on. The white sparkle type thing, are you referring to these lines? Okay, so these lines, this is called the Tycho crater, and it's an impact crater, and you see these lines are the remnants of the impact, the debris as it fell off from the crater. All right, so you see that it was a huge impact. The far side has lots of impact craters and very little volcanic activity. Then we see the North Pole. This would be the top. Okay, so if we were to look at it from in the perspective of also the Earth, all right. So this is the North Pole of the Moon, all right. So now we actually have satellites that are orbiting the Moon that are able to take these pictures, all right, because of course, imagine that if this is the far side of the Moon, we never see this side of the Moon, okay? And see, so this is the North Pole, this is the South Pole, okay? I don't know exactly why is it so different in color, okay, in the coloration, so I don't think that is a real effect, okay? But see the impact craters that are here on the south pole of the Moon. Really deep and huge craters, really. Okay. So why do you think that there are more craters on the far side than on the near side? Why would it be that there are more craters on the far side of the Moon than on the near side? Mac, you mentioned above there that the Moon took some hits for us, doesn't it? Okay, where do you have a comment there? Yeah, so it's more exposed, that's right. Yeah, so sorry, I sometimes cannot keep up with all the comments. Yes, so the far side is really less protected, so any asteroids or meteors that are around this area in the solar system, if they are going to hit the Moon, if they are going to go in the path, they are going to hit the far side of the Moon. Most likely, if these meteors were to be facing the near side of the Moon, well, the Earth is in between. Okay, so they would actually go between the Earth. They would hit the Earth before they hit the near side of the Moon. Okay, so we are kind of protecting each other. We are kind of, so the Moon, the far side of the Moon is protecting us, and we are protecting the near side of the Moon. All right. Doesn't the Moon have barely any atmosphere? That is correct. That is true. So another important thing to understand is that the moon has almost no atmosphere at all. Okay, and the reason for that is because there's very little volcanic activity. So the volcanic activity of a planet is one of the things, one of the reasons, also the mass of the planet is the other reason why a planet or a celestial body could have an atmosphere. So the moon is 1/4 the size of the Earth, all right? So 1/4 the size of Earth, okay? Why are the sides smoother than the poles? I don't know, other than the probably what happened is that the poles also have a lot more hits of meteors because they are more exposed. Okay. So Sam, you mentioned there that that's actually big, isn't it? Yes, actually. The moon and the Earth are one of the couple of, if you wish, planet satellites that have the great, the greater proportion, if you wish. Okay, so the moon is relatively large as a satellite compared to the Earth being just 1/4. Okay. That 1 million Earth feet in the sun. Yeah, well, so yes, everything compared to the sun, everything is really small. Okay, so certainly that is the case, Annika. But for example, Io, the one of the moons of Jupiter, that is similar to the moon, but Jupiter is much larger. Okay, so you see that would be a very different relationship. You have a much larger planet and a little moon. The moon doesn't get any rain. Okay, so one of the effects of not having atmosphere is that there's no rain. Okay, there's very little water. They have found some ice water, frozen water in the poles, in the southern pole and the north pole of the moon, but there's no rain, there's no evaporation, okay, and there's no winds, because the wind is like we were talking in the geography class, is basically the effect of the movement of air, okay, and so if there's no air, then there's no wind. All right. Also, another interesting thing is that the temperatures of the moon are very brutal, really. Okay, so let me see if I go here to the article on Wikipedia on the moon. All right, we have here some part of the temperature. Okay, let's see, where is it? Okay, here. So the temperature, it goes minimum 100 Kelvin, so that is about 250 degrees below zero. Okay, so extremely cold, and the maximum is 390, so that is about 130 above zero. Okay, so it goes from very, very cold to very, very hot. So wherever there's sunlight, it's really hot. And wherever there's shadow, it gets very cold. Okay, let me see some of the chat here. Okay. So yeah, we mentioned that there's no rain. Then what is the mare imbrivium, sea showers, rain, mean? So mare means ocean or sea, okay? And anciently, the people that gave the names to these things, they thought that these dark spots were oceans. They thought that they would have actually rain, and so they named the darker spots mare, okay, sea of serenity, sea of tranquility, you know. So the different names in Latin reflect that. But we know now that there's no water in this, okay, so these are not really seas. They are just all volcanic areas where there was some volcanic eruption, and this is the basaltic bed of the surface of the moon, okay. So this happened about 3-4 billion years ago. So all these things were happening at the formation of the moon, right at the same time, okay, of the formation of the solar system. The question here, Annika asks, was the moon used to be covered in volcanoes? No, there wasn't a whole lot of volcanic activity in the moon. So one of the things that happened, let me go here to this, too fast. This slide, okay, just shows the composition of the moon, okay. So the moon gets about 260 degrees high, yeah, very, very hot, because there's no atmosphere, there's no protection from the sun rays, okay? So the sun hits and it hits you full force there, okay? So the atmosphere is really the thing that protects us the most. So Mare Imbribium, is it a mountain, a volcano? Is not a volcano, it's basically the lava bed of an ancient eruption. All right, there's no remnants of these volcanoes nowadays. Does the moon still have volcanic capabilities? They seem to believe that there are some moon shakes, okay, instead of earthquakes, there's moonquakes, okay. So, but there's very little volcanic activity, and the reason for that is because the core of the moon is relatively small. So the core, that is the liquid part, okay, is very, very small relatively to the rest of the moon. And so all this area of mantle is pretty solid, okay? And the crust is also very solid, and so the small core doesn't have enough power and to move the whole mantle, all right, to produce eruptions. So the difference in the yes, you are really chatting a lot. I like it. I don't mind at all. Okay, but sometimes I cannot keep up. So if you can keep up with me talking and you chatting, I'm fine with that. All right. So, but what happens is that the Earth, the mantle of the Earth, is kind of plastic. So the core of the Earth is a lot larger relatively to the Earth. So if we were to draw this, the core of the Earth would be all the way up to here, you know, and then the mantle is plastic, meaning that it's not liquid, but it moves, okay? So there's convection movements between the crust of the Earth. Plastic means that is flexible, that it moves, not that it's made out of plastic, but it means that it has plasticity, okay, that it has movement, all right? And so that is why there are volcanic activity on the Earth, is because the core is a lot closer to the surface and the mantle moves, and then there's breaks between the plates, okay, and so the magma of the core can go through and then erupts in a volcano. Well, the core of the moon is so small and the mantle is so thick and is not very plastic that there is very, very little interaction between the two, and so there's no more volcanic activity here in the moon. It used to have volcanic activity, and the result of that we can see it by these lunar seas or maria, okay, that basically are the remnants of this volcanic activity. All right, let me see some of the things going on in the chat so I can keep up with that. Does the moon have gravity? Okay, so the moon has gravity. Every body has gravity. Okay, all right. There is gravity, just a lot less than there is on the Earth. So it's about 1/6 of the gravity. So gravity, remember that is related to the mass of the body. It has a core. It has mass. So the reason why the moon has gravity is because it has mass. Everything has gravity. Okay, I have a gravity. You have gravity. The thing is that, of course, we are not very massive, and so we do not exert that much a gravitational pull. Okay, all right. Oh, this now really got confusing. Let me see. Okay, here is where we are at. Okay. So the core of the moon, if it's so hot, why does it not like burn the moon into ash? So the reason why the core of the moon or the core of the Earth is hot is because of a radioactive activity that happens because of the pressure of the elements. Okay, so imagine that the core of the moon has all the weight of all the mantle and everything else on it. And so things get pressurized a lot. As the pressure increases, the temperature goes up. Okay, so when you have higher pressure, you also heat something up. And so here the core of the terrestrial planets is very hot because of the pressure at which the elements are there. Okay, so but this is very dense. So it's hot. It doesn't mean that it burns things. It just means that it is hot. Okay. Let me show you, okay, another thing. So we were looking here in this part at some of the different craters and the seas. So all the dark areas are seas. We explained that they are not really water, okay. And then we have some craters, some of the big craters, like I mentioned, this one of Tycho. Tycho crater is named after Tycho Brahe. He was one of the astronomers at the time of Kepler. Here we have a crater called Kepler, all right, in the ocean of storms. We have the Kepler crater. And this one here is the Copernicus crater. It's not one of the biggest ones. Remember that here on the near side, we don't have some of the larger ones. So this is Copernicus, okay. Tycho is much larger, and then if you go to the far side, you see that they are even more, much larger craters. But just to give you an idea of the size of these craters, let me show you this comparison that I got here. So this would be a profile of the Copernicus crater, okay? So it would be from the west rim of the crater to the east rim of the crater, okay? from the top to the floor is 12,600 feet. All right, so that is the depth of the crater. And the width of the crater is about 56 miles. Okay, rim to rim, 56 miles. This here is the profile of the Grand Canyon. All right, have you been to the Grand Canyon? Have you seen the Grand Canyon? So the Grand Canyon is just incredible. It's amazing, you know, how big it seems and how far the rim, you know, is from the south rim to the north rim and deep and everything. Well, so this is the Grand Canyon. This is the Copernicus Crater. Okay, yeah. So I don't want my car to break down there. Yeah. So yeah, Nathan, you live very close there to the Grand Canyon. So imagine living, you know, looking into the Copernicus crater from the one rim to the other. Okay. So really huge distances, you know. So you see that, and that is this crater here. Okay, so we were looking from east to west, so probably, you know, is this distance here 56 kilometers wide. Okay, but that is not even near as big as some of these other craters. Okay, so we are going to talk more about where the lunar missions landed and so on. I want you to study on that. All right, so that gives you an idea of the size of these craters. Now let me go a little bit back about this volcanic activity and what happened. There are several theories about how the moon was created. One of the most popular and accepted theories nowadays is that at the time when the solar system was being formed, about 4.5 billion years ago, all right, so if we have the Earth here, there was another huge planet, okay, about the size of Mars, that hit the Earth, okay, so these two planets basically collided, and then the explosion, the debris of the explosion, you know, form a belt basically of material around, and that material started coalescing, basically hitting each other and creating the moon, impacting, you know, so there was a huge impact, okay, on the Earth, and out of the explosion and the material of the explosion of that impact, you would have that then over time they would this material would get you know, together, okay, and form the moon. All right, so now during that time of formation there was a lot of activity, a lot of bumping and hitting and forming, and that caused a lot of also volcanic activity. Yes, guys, if you want to have that, Annika, I agree with you. I'm going to kind of raise a flag. If you need to say things in the chat that are not relative to the class, okay, you can take them in the private conversation, all right, or you can do that later, okay. But so I'm trying to keep an eye on the chat for some useful things, and then all of a sudden I get this "let's get married" thing, and I don't know what the world is that having to do with the class. Okay, so all right, so I don't mind you chatting, but let's concentrate on the class. Okay, so during this period of the formation of the moon, one of the things that happened also is that you are all in trouble now, yeah. one of the things that happen is that the gravitational pull of the Earth move the core of the moon off center. Okay, so let me see if we can see that kind of how is depicted. So if this is the Earth, okay, so let's put here E for Earth. All right, so this is the Earth, this is the moon, all right, and this is the core of the moon. So imagine at the time when the moon was being formed and things were moving and more malleable, more plastic, okay, when things were more plastic, the gravitational pull of the Earth pull the center, the core, the heavy core of the moon off center, and you can see that this is off center, it's not right on the center of the moon, but it pull it off center closer to the Earth, all right? And what that causes is that as the moon orbits around the Earth, the center, okay, is gravitationally attracted to the Earth, and so is always facing the Earth, all right? So then you have that is the reason why the moon always faces the Earth on the same side, okay? That is on the exactly, Ben. So that is the reason why the volcanic activity, all the Mars, the oceans, you know, the volcanic beds that we see are on the near side, is because the near side, the core is closer to that side. Okay, so that is particularly right. And so if there's any volcanic activity, all right, it would go over here on this side as opposed to the far side. All right, so it is lopsided. So the moon is kind of a little bit eccentric, okay, off center, all right, but the core is really off center. That is similar to how if you have an egg, you know, the egg, of course, is very exaggerated by the yolk of the egg. The heavier part of the egg is on one side, all right? And so that is kind of the same thing that happens with the moon. Not that much, okay? Okay, yeah, all right, so you boil the egg and then the yolk solidifies really there at the bottom, okay? And so that is the reason why the moon is locked into facing the Earth on the same side, okay? Let's see another effect between the moon and the Earth is the effect of the tides, okay? The tide is the, let me see if in this article is really good on Wikipedia about the moon, okay? And so I invite you to read it. So here you see presence of water. You have more information about the amount of water, volcanic activity, and so on. So really it's very interesting. Okay, here we have also a graphic showing the relationship, the orbit, okay? And let's see here the tidal locking. Let's see if this animation comes a little bigger. So this side shows the moon tidally locked, meaning that the center is off center, so it's always facing the Earth, all right? So you see it, that the moon does rotate, but it rotates at the same time that it does a revolution around the Earth. This one here would be the case, an animation, if the moon were not rotating, if it were not locked So then you would be able to see all the sides of the moon. But this is not really how it happens. This is actually how it happens and why we always see the same side of the moon. Does that make sense? Okay. Scientists also use this this feature to keep satellites. When they have satellites in orbit, they put the heavier part, okay, of the satellite towards the Earth, and so that part is always facing the Earth. All right. Oh, yeah. So let's talk about the tides. So the effect of the tides is basically that water is pulled at different times, okay, because of the gravitational pull of the moon. Okay, so we have that article there of tides, and so the moon causes the water of the Earth to increase in the area, okay, that is facing the moon, but also in the area that is away from the moon. Okay, so whenever you have the moon-Earth relationship, you are going to have two places with sublunar, okay, sublunar meaning under the moon, tide, high tide there, and then antipodal, meaning on the other side, okay, on the other pole of the moon, you are also going to have a high tide. All right. In the areas that are perpendicular to the moon, those are the areas where the water eaves out and you have low tide. Okay. So the tide isn't that far off the Earth. So the tide is on the Earth. Okay. Yes, of course, this graphic is exaggerated. Okay, because this is basically representing the amount of water. Okay, how the water moves on the Earth, but it is certainly just a graph. Okay, it's not that big, but it is something big enough that if you are on the ocean, you notice it. You need large bodies of water in order to notice the tide. For example, in lakes, you would not notice the tide. Okay. Yeah, so it's really beautiful to explore a tide pool at low tide. You see lots of creatures and animals and vegetation. It's very, very interesting. Okay, and that is in areas that are low, that are uncovered, okay, of water during low tide, and they are covered at high tide, and so they have both the best of both worlds. They have water and air for all the creatures to live in. Okay, so here I have another graph that shows the different tides, and so we have what is called spring tide. Okay, is the sublunar type and the antipodal tide. All right, it doesn't mean that anything to do with the season spring. It means that spring because it comes up. All right, there's also a neap tide so a spring tide are the larger tides is when the gravitational pull of the moon and the sun work together. All right, so when the moon is here on new moon, you have that both the Earth is feeling the gravitational pull of the moon and the sun together, and so the tide is larger. Okay, when the moon is full, you also have the gravitational pull of the moon and the sun kind of also working together as far as the movement of water goes. All right. When you have the quarter moons, all right, so the moon is perpendicular to the sun, the gravitational pull is not as large. So you also have a tide, but it's called a nip tide, all right? So the bulge of the water, okay, instead of, if here it is high and this one is also high, when you have a nip tide, it's just a little bit and then a little bit, okay, at high tide. So that is the difference. But here you see that the moon and the sun are at right angles, okay? Instead of being working together, they are kind of counteracting each other. Here I have another picture kind of showing the same effect, all right? So if we have the sun and the moon, at new moon, you would have a spring tide, a large effect here on the sublunar tide and the antipodal tide. When the moon is at the quarter, you have a nip tide, and so see here the effect is visible, but it's not as large as this one. And then you also have the nip tide on the other side of the moon. At full moon, you also have a spring tides larger, and at the first quarter, you have the nip tides lower. Okay. So how big is the difference between a solar tide and a lunar tide? Actually, the sun, even though the sun is so massive, okay, and it has really a huge gravitational pull on the Earth, that is what keeps the Earth moving around the sun, it doesn't have as large of a tidal effect, okay? So the tides are all made because of the moon. Now, when the moon and sun combine, then you have the spring tide. When the moon and sun don't combine, then is where you have the nip tide. So there's not really something exactly, it's because the moon is a lot closer. Even though it is smaller, it is a lot closer. So we don't have really solar tides. We have really lunar tides. And the effect is either large if the moon and the sun are working together, like in the case here of the new moon or the full moon, or if they are just working independently, and so you have just the effect of the moon, like in this case you have the nip tide. So again, both during new moon and during full moon, the gravitational pull of the moon and the sun combine. Okay, so because of that, you have that some places have two tides during the day, two high tides during the day. Most places on the Earth have four tides, all right? And so sometimes they have what is called semi-diurnal tide, meaning that you have four tides per day. Other places have only diurnal tides, meaning that there's only two tides per day. And then you have some places where you have a spring tide, nip tide, spring and nip tide. So the effect changes. And it's not constant all over the world. It really changes between one place and the other. Okay, so this is the difference in feet of the high water mark. Okay, so this would be 2.5 feet above the average, and it goes almost to 3 below. So about 6 feet difference, nearly 60 feet difference on the tides. There are some places that have a lot larger tides. Okay, and it depends really on the place. So if you are in the ocean, if you are close to the shore, that is where you notice the tidal effect. In the middle of the ocean, the tidal effect is there, but you don't notice it at all. because you are surrounded by water. Okay. I'm guessing that the more tides you have, the closer you are to the equator. Is my hypothesis feasible? That is a good question, Sabrina. So I encourage you to find out, is that a good hypothesis? So everybody could do that kind of as an exercise. So the hypothesis is that you have a higher tidal effect closer to the equator. Let's find out, okay? If I remember correctly, that is not the case, but I really don't know, and I don't know why. So let's find out and see if we can find that out for next class, okay? So that is a good hypothesis. Okay, let's test it. And the way to test it, of course, is by looking at the data, all right? So we have to find some tables, okay, tidal tables in different parts of the world, all right? Now you can search for that online and so on. And so let's test the hypothesis to see if the tides are higher closer to the equator, or where are they higher, where you have more variability. Is that a good idea, guys? All right. Should we submit what we find with the assignment for this lesson? Yes, let's do that, Annika. Okay, so submit it. I'm going to change the assignment for this lesson to include this, okay, to include this hypothesis. And so I'm going to add it as an assignment. And so you find out, submit it, and then we are going to look at the results, what you find next class. Okay? All right. So let's go. Yes, Nathan?
What was the question we were supposed to find out?
So the question is this. This is the hypothesis that Sabrina put forward. Okay, Sabrina, do you want to explain your hypothesis? Let's see. Okay, Sabrina, you can unmute yourself. Okay. All right. We may hear a lot of different noises now, but Sabrina, if you want to come in and so I'm going to mute everyone and see if I can find Sabrina. Okay, there is Sabrina, and unmute her. Okay. Oh. All right. So let's make sure we copy. So what I understood of Sabrina's hypothesis is that there's more tides. Okay, it says, I'm guessing that the more tides you have, the closer you are to the equator. Okay, so if you have 4 tides, it's because you are closer to the equator. And then in the areas farther from the equator, the hypothesis is that you would have less tides, just a diurnal tide. Okay. All right. The mixed tide is close to the equator. The diurnal is near the poles, and the semi-diurnal in between. Okay. So then Sabrina's hypothesis is that this case scenario, okay, is closer to the equator. Okay, so the hypothesis is that this would be closer to the equator, meaning 0 degrees latitude. Then the mixed tide, it would be in the middle latitudes, let's say 45, 40 or something degrees latitude. And then the diurnal tides you would have in the higher latitudes, okay, 80 or 70 and so on. All right. So great hypothesis. So which places have what different types of tides? That is what we'll try to find out. Okay, let's see. Here we have the spacewalk, all right? And you know how we mentioned that one of Kepler's laws is that all the planets and satellites, they have an elliptical orbit, okay? So let's see if the moon also has an elliptical orbit. So if you look at this closer, it seems that it's pretty round. But let's see when we accelerate the time, okay, and we move really fast. Okay, let's see, come on. Let me go and let's all right. Oh, this is moving the other way. So let's move it forward. Okay, let's see if we can move by days. All right, so now we are moving. Okay. So here you can actually see that the orbit is eccentric. Okay. And you know, you have one place that is closer. It seems that this area is closer here to the Earth, but the eccentricity is very, very low. When I was looking this in Wikipedia, okay, on the moon, you have here in the characteristics of the Earth. All right, let's see, eccentricity 0.0549. So the closer you are to zero, okay, is the closer you are just to a perfect circle. Okay, so the higher the number, the more eccentric the ellipsis is. But in this case, it's near circular. Okay, so let's stop that and then look here at the moon. We see the different areas of the moon. So it's not, the moon receives light all around, okay? Sometimes in the far side, sometimes in the near side. It really depends on where the sun is with respect to the moon itself, all right? So here we see some of the seas, but most of the sun is really on the far side here. And if we go out, okay, let's see where it is, this in relation, okay? So yeah, you see that the moon is kind of in the quarter, you know, phase here. All right, and so you only see part of that illuminated. We are going to talk more about that in next class. All right, so yeah, I really love this app. It's really cool, and it has lots of good information. So here you can see even some of the pictures on the moon and everything. We'll see some of those in next time. Okay, so we were saying that the moon doesn't have an atmosphere, and because of it doesn't have an atmosphere, there's no wind, there's not much activity, and so the craters on the moon stay. Okay, so whenever something hits the moon, it forms a crater and is going to stay there forever, basically. All right, and so that is why when we see, you know, the different craters, you can see that newer craters are on top of older craters. See, here you have a very good example of that, how this crater is older, and then you have these other ones that are newer that impacted on top. Okay, but there's nothing to erode or change the impact of the moon. Okay, and also what happens on the Earth when there's a meteorite, okay, entering the atmosphere? What happens here on the Earth when a meteorite enters the atmosphere? And by the way, is you know, There's lots of meteorites every day, all the time, that are hitting our atmosphere. That's right, Sabrina. They burned up. That's correct, Mac. So most of the meteorites burned up on entry in the atmosphere. So the atmosphere is basically a shield that protects us. So very few meteorites are large enough to survive entry into the atmosphere and then hit the Earth. Okay. Also, because of the amount of water that we have, a lot of the meteorites that make it into the water, okay, they hit the water instead of hitting the Earth. Okay, sometimes they do, but that is really one of the blessings that we have, of how we have not very many craters here on the Earth. That's right. So that is why there are so many craters on the moon, because nothing burns up. There's no atmosphere to stop any of the meteorites. And then there's also no erosion. There's no water to catch the meteorites that make it. And so that is the reason why there are so many craters on the moon. Okay. The atmosphere here in the Earth really is a barrier, is a protection for us. Okay. In the class, there's a very interesting concept where they talk about, okay, that our testimonies can provide an atmosphere of a spiritual protection. All right. So think about that, how our testimonies and the way that we live is kind of an atmosphere, is a shield to give us a spiritual protection. What are some of the things that we need protection from? What are some of the things that we would need a spiritual protection? Temptations, Satan's attacks, and these temptations come in many forms. All right. Sometimes I am tempted, by my thoughts. Okay, I think that those are kind of Satan's promptings, that he tries to have me thinking about things that are not good, that are not correct, or about doing things that are not right. Okay. Sometimes the attacks are more direct, by things that we see on the screen or on TV. Okay. Sometimes we may be tempted by, online. There are so many places that have advertisements that are really bad. Verbal assaults, that's right, yeah. How many times people treat others very bad when they are texting, okay? And then we feel tempted to answer back, okay? To answer back and to follow that back with more verbal assaults. So those are really some of the temptations, okay, that we can feel in our daily life. How does our testimonies protect us from these things? Yeah, sometimes Satan makes us think our self-esteem low and to think poorly of ourselves. I struggle with that. Okay, many times that is a big temptation. All right. Sometimes we get into religious disagreements with other people. Okay, those are not very productive. So how could our testimonies provide a spiritual atmosphere of protection? The meteorites of the adversary need to burn up through the fire of our testimonies. Oh, beautifully said. Very good, Sabrina. Really good. Okay. So our testimonies have to provide kind of a shield through which we monitor our thoughts. Okay, molto bene, muy bien, buenissimo. Okay, what else? Yeah. So our testimonies can provide a shield to these temptations, to thoughts, demeaning thoughts to ourselves. If we feel that we need to answer back to someone rudely or something like that, our testimonies can tell us, no, that is not correct, and not text back. Yeah, so with the knowledge of who we are and that we came here for, the testimony shields us from a lot of those temptations. Let virtue garner your thoughts unceasingly. Yeah. Okay, so when we let virtue and virtuous thoughts, the scriptures, the words of the prophets, good things, be in our thoughts all the time, then we create really a spiritual atmosphere that is conducive to good things. Okay, to better thoughts and be able to resist those temptations. Keeping our covenants also help us to do that. Okay, they provide also a protection, and having a testimony of the gospel help us to keep our covenants. How do you feel when you do family history work? How does that help you to provide an atmosphere of a spiritual protection? No, we are ending right now. Sorry, I'm a little late. Okay, but I have loved the conversation. So, Nicola, would you like to offer the closing prayer for us today? Okay. Yes. We feel protected when we do family history. Annika says that we feel protected. Okay, that is excellent. So I'm going to change, guys, the assignment here in the class. I'm going to add another activity, to test the hypothesis that Sabrina proposed about the tides. Okay, so I'm going to update that, and we'll see how we do that next time. Okay, Nicola, go ahead, and thank you very much for participating in class. Let's have a prayer, and then we'll finish next time. Okay.
Can you hear me?
Yes.
Okay. Our dear Heavenly Father, we thank you for this day that we're able to meet again together as a science class. Thank you for Mr. Rivoldi and his efforts to teach us about the moon and about how we can liken this lesson to our lives. Please help us all with safety as we go about our various activities the remainder of the day. And please help all of us to be able to make it to geography class tomorrow and enjoy that. And I say these things in Jesus Christ, amen.
Amen. Thank you. Thank you very, very much. We'll see you tomorrow or next week. Okay.